In Chapter 15, we'll take a look at the low power modes for the TM4C 1294NC PDT device and the operation of the Hibernation Module. In the lab, we'll measure the device current and observe wake-up characteristics. The Hibernation Module incorporates a 32-bit real-time seconds counter with high resolution and a 15-bit sub-seconds counter. The match register is also 32 bits with a 15-bit sub-seconds register and is used for time to wake up and interrupt generation with high resolution. The real-time clock pre-divider trim can be used for making fine adjustments to the clock rate. The module features a hardware calendar functionality for tracking year, month, day, day of week, hours, minutes, seconds with leap year compensation and 24-hour or AM/PM configuration. There are two mechanisms for power control. On-chip power control can be accomplished using internal switches under register control, or system power control for the entire board can be done through a discrete external regulator. VDD supplies power to the device when it is valid, even if battery voltage is greater than VDD. The wake pin is a dedicated pin for wake up using an external signal. The external reset and up to 4 GPIO pins can be configured as wake-ups as well. The real-time clock is operational and hibernation memory is valid as long as either VDD or the battery voltage is valid. Low battery detection signaling and interrupt generation are available with optional wake-up on low battery voltage. The GPIO pin state can be retained during hibernation. This is an important feature when the microcontroller powers down surrounded by still powered circuitry. The clock source for the Hibernation Module can either be the internal low frequency oscillator or a 32 kHz clock crystal or oscillator. 16 32-bit words of battery-backed SRAM are provided to save the processor state during hibernation. You may find this odd since the microcontroller has both flash and EEPROM. The fact is, SRAM is much faster and lower power than either of these alternative memories. SRAM is a much better choice for saving processor state during a power failure when current consumption and speed matter greatly. An SRAM memory cell is also immune to physical corruption, unlike flash or EEPROM. There are programmable interrupts for a match of the real-time clock, an external wake event, and low battery voltage. Note the separate power and oscillator inputs on the left. If there is ever a question whether or not your device is in hibernate mode, you can simply look at the HIB output pin shown on the right. Individual peripheral modules and the clocks that run them can be enabled to operate during sleep modes. Of course, this is dependent on whether or not the clock is operating during that sleep mode. The 4 power modes are run mode, sleep mode, where the processor clock is stopped, deep sleep mode, where the system clock is stopped and the PLL and flash memory are off, and hibernate mode, where only the Hibernate module is powered. Current consumption is highly dependent on the processor speed, which memory is being exercised by the code, what peripherals are operating, and other specifics. The current consumption shown here were measured at 25 degrees C, 3.3 volts VDD and VDDA, except in hibernation mode where it was 0, and 120 MHz, except where noted. The flash PM bit enables low power flash memory mode. In run mode 1, all the peripherals are on. In run mode 2, all the peripherals are off. The low-cost LaunchPad board does not have a battery holder. VDD and VBAT are wired together on the board, so that disables the battery-only powered hibernation modes. We'll use the JP2 test pins to measure the current for the microcontroller only. Most digital multimeters have an issue with equivalent series resistance. If you have the DMM set to measure a very low current, this resistance may not permit a higher current to flow when needed. You'll have to switch the mode on the meter. In Lab 15, You're going to measure the current draw of the TM4C device when it's placed in run and hibernate modes. The low-cost Tiva LaunchPad doesn't have a battery holder, so the battery power input is connected to the power for the CPU. This will shorten our experiment somewhat, but you'll see the device wake up from the real-time clock and wake pin events.